Welcome to Grade 7 Mathematics. In this lesson, we'll take our first steps into algebra, where letters stand in for numbers we don't yet know. By the end, you'll write expressions, simplify them, and use them to solve real problems with confidence. Here's our plan for the lesson. We'll discover what algebra is and why it's so useful. We'll turn words into expressions, then evaluate them by substitution. After that, we'll collect like terms, expand brackets, and finish by factorizing expressions and substituting into formulas. Let's begin with the big idea. Algebra uses letters to stand for numbers. A letter like x is called a variable because its value can change. When we write x plus 5, we mean 5 more than some number x, whatever that number turns out to be. The power of this is that one short rule can describe many situations at once. Instead of solving each problem from scratch, we write a general rule and use it again and again. Now let's learn how to build these expressions from words. Algebra starts by turning words into symbols. 3 more than x means we add 3, giving x plus 3. Double a number y means 2 times y, which we write as 2y. 7 less than n means we subtract 7, giving n minus 7. A number m shared by 4 means m divided by 4. And 5 times t, then add 2, becomes 5t plus 2. Notice that 2y means 2 times y, with the multiplication sign left out. Once we have an expression, we can find its value when we know the number a letter stands for. This is called substitution. Let's find 3x plus 4 when x equals 5. First, replace x with 5, giving 3 times 5 plus 4. Remember the order of operations, so multiply first. 3 times 5 is 15. Then add 4 to get 19. So 3x plus 4 equals 19 when x is 5. To simplify expressions, we collect like terms. Like terms use exactly the same letter. 3x and 5x are like terms, so we add them to get 8x. In the same way, 7y minus 2y is 5y. Unlike terms use different letters. 3x and 5y cannot be combined, so 3x plus 5y stays exactly as it is. Only terms with the same letter can be added or subtracted together. Expanding means removing brackets by multiplying. Let's expand 4 times the quantity x plus 3. The 4 outside multiplies each term inside the brackets. 4 times x is 4x. 4 times 3 is 12. So 4 times the quantity x plus 3 equals 4x plus 12. Every term inside the brackets must be multiplied, not only the first. Factorizing is the reverse of expanding. We take the common factor out and place it in front of brackets. Let's factorize 6x plus 9. The largest number that divides both 6 and 9 is 3. 6x is 3 times 2x and 9 is 3 times 3. So we take 3 outside, leaving 2x plus 3 inside the brackets. 6x plus 9 equals 3 times the quantity 2x plus 3. You can always check by expanding it back again. Formulas are expressions we use again and again. The perimeter of a rectangle is 2 times the quantity length plus width. Let the length be 7 and the width be 3. We substitute these values, giving 2 times the quantity 7 plus 3. Brackets first, 7 plus 3 is 10. Then 2 times 10 is 20. So the perimeter is 20. The same formula works for any rectangle, whatever its length and width. Algebra is not only for the classroom, it describes the world all around us. If a bus fare is 400 francs each, the total for n passengers is 400 n. If maize costs 350 francs a kilogram, then k kilograms cost 350 k. A phone plan might charge 50 francs a minute plus a fixed 1,000, written as 50 m plus 1,000. And the perimeter of a field uses the same formula we met earlier. Whenever a quantity depends on a number that can change, algebra is the language we use. Before we practice, let's avoid the traps that catch most learners. First, 3x means 3 times x, not a number in the 30s. Second, You cannot add unlike terms, so 3x plus 2y stays exactly as it is. Third, when expanding brackets, multiply every term inside, not only the first. And finally, 2x and x squared are different. 2x is x plus x, while x squared is x times x. Keep these in mind, and your algebra will stay accurate. Here is a quick summary of the key ideas. A variable is a letter that stands for a number. We write words as expressions, where more than adds and less than subtracts. To evaluate, we substitute the value and follow the order of operations. We collect like terms and leave unlike terms apart. Expanding multiplies the outside by every term inside, and factorizing takes the common factor back outside. Now let's check how much you remember with 3 quick questions. Here is the first question. Evaluate 2x plus 3 when x equals 4. Replace x with 4, giving 2 times 4 plus 3. 2 times 4 is 8, and 8 plus 3 is 11, so the answer is 11. Question 2. Simplify 5x plus 2y minus 3x plus y. Collect the x terms. 5x minus 3x is 2x. Collect the y terms. 2y plus y is 3y, so the answer is 2x plus 3y. Last question. Expand 3 times the quantity 2x plus 5. 3 times 2x is 6x. 3 times 5 is 15. So the answer is 6x plus 15. Wonderful work. You can now write expressions, simplify them, and use them to solve real problems. The foundation for everything ahead. Take a moment to try a few problems on your own. In Module 5, we'll build on this to solve linear equations. I'll see you there.